So this during these rainy months, we might have to reschedule the class a little bit here and there.
Yeah,
So
it's fine.
yeah, because when it does rain over here, it also there are thunderstorms and
Uh,
the cable operator, what he does, he switches off the routers.
uh,
That's why even if I want to, I cannot give you there won't be proper stable connect. I can use the mobile, but
mm,
that won't be giving a proper feed.
yes.
So okay, let's start again. So reaction intermediate and carbocation, and as you can see over here, we have a carbon at the center, and
Mm,
then these three hydrogens are directed towards the vertices of a triangle. Then you have
mm,
to have you enclose this with a parenthesis or a third bracket, and then you put a positive charge over here. The angle between these HCH are
mm,
120. Okay,
mm, mm,
and how do you know the hybridization of this carbon? If you go back to the chemical bonding concepts, okay, you know
uh,
that carbon is
yeah.
4, hydrogen is 3, and for the plus charge we have minus 1, and the
Mm,
number is 6, so it is less than 8, so you divide by 2 and not by 8, and that's how
mm,
you get the steric number. The steric number is 3.
yeah.
So then it should be S, you should begin with S, and as the energy level goes, S followed by P and another
Mm,
P, so the count is 3, so we have sp2. That is
mm,
how we have it.
yeah.
Okay, now then we have B. So carbocation is planar, it will be sp2 hybridized, as I have
Mm,
said now that it has a vacant p orbital,
mm,
so it will be accepting electrons,
mm,
and the p orbital is perpendicular to the plane of the molecule. It is diamagnetic in nature, that means it is having 6 electrons.
mm,
If it has if it had odd number, then it would be having unpaired electron. If it is having even number, then it means it is having no unpaired electrons. Got this concept? Okay.
yeah.
Since it is having the capability of accepting electrons, so it is electrophile.
Mm,
So it is electrophile. Acha. Now carbon is not a very electron rich atom.
mm,
Okay.
mm,
Neither a very electron rich atom or neither a very electron deficient atom. So if
mm,
you have a positive charge on this,
mm,
it can be stabilized. This type of a species, even though it is an intermediate, can be stabilized by
mm,
pushing in more electrons towards the carbon center.
mm,
So if you have groups in place of
mm,
hydrogen that
mm,
donate electrons towards the carbon,
mm,
that will increase the stability of the carbocation.
yeah.
So we say electron donating groups
Mm,
stabilize carbocations,
mm,
and electron withdrawing groups
these tables.
carbocations. So
Mm,
now you can expect questions regarding stability of carbocations being asked to you.
mm,
Okay. They are also called carbonium ions. Now these type of things you are not studying when you are in class 12.
mm,
What are carbonium ions? Just like ammonium ions,
uh,
when NH3 goes to NH4 plus,
uh,
right?
uh,
Whenever we have something having a positive charge on the central metal,
mm,
we are calling them as onium ions.
mm,
Okay. So carbon, when it is having a positive charge, it is called carbonium ion. Nitrogen, when it is having positive charge over it, just like ammonium ion. Even
mm,
your phosphorus,
mm,
when it is having a positive charge on it, we are saying phosphonium ion.
yes.
Similarly, sulfur, if that is having positive charge over it, we will say
Sulfur.
very good. Okay, so these things. If you want to write, you can write, or if you want to record, you can record. Okay.
Yeah, I got it.
Okay. Now let's uh, do a similar thing for
Mm,
hybridization calculation. Carbon is 4, hydrogen is 3,
mm,
and negative charge means you add 1. So this is how we calculate steric number. Now you have the number to be as 8. So
mm,
if you add like this,
mm,
what you need to do is first of all find the total electron count for
mm,
this molecule. Okay. So what is that? It is CH3 minus C, 4 carbon, 1 valence electrons.
mm.
Hydrogen 3,
Three.
its valence
Yes.
electrons. 1 is for the negative charge. So
Mm,
we have 8. If the number is 8 or less than 8, we divide by 2.
mm,
And the number that we get is 4. Now if you use the counting again, so you can start with your, as we do as kids, we
mm,
count 1, 2, 3, 4 using our finger
mm.
marks, isn't it? So we use from
Yeah.
the ring finger and like that we do, no? So so you say the so you begin with S, then you have
Three.
3p. So the hybridization becomes sp3.
Mm,
That is what we have over here. But it is having in one of the sp3 lobes lone pair.
mm,
And for structure, we know we do not see the lone pair.
mm,
While we are doing structure determination, we only
mm.
see the bond pair, no the lone pair. So if you remove this
Yeah.
lone pair, then you think of this structure. It is a pyramid.
Mm,
It is a triangular pyramid, not a square pyramid. Triangular base, na? This is
mm,
having a triangular base. We join the hydrogen, hydrogen, hydrogen. It makes a triangle.
mm.
So it is a trigonal pyramidal structure.
Pyramid.
Okay, fine.
Mm,
So, but the hybridization, so that's why we are saying this is pyramidal shape and it is sp3 hybridization. Now, since
mm,
it is having a lone pair,
mm,
that means carbon having a lone pair, it will act
mm,
as a nucleophile.
mm,
Again, total electron count is 8, so it is diamagnetic, cannot be paramagnetic.
mm,
Now, carbon is not that electron deficient, not electron rich.
mm,
So, if it is having positive charge, it needs to be stabilized by giving negative to it. Okay,
mm,
and it is having extra negative charge, then something needs to pull it from away from it to stabilize it. Understood?
mm,
Because you think this way in a periodic table in a row,
mm.
fluorine is at the end, so it is highly electronegative. Ah,
Yeah.
so if fluorine becomes fluorine minus, it is stable. Why? Because it wants electron. Acha. Sodium, it is on the left hand side. So
Mm,
sodium becomes sodium plus. It wants to get rid of the electron. That sense.
mm,
Okay, so sodium plus and F minus they are stable as
mm,
their cations or anions. Okay,
mm,
but carbon you make positive, it is not stable. Why? It says give me some electron. Okay,
mm,
carbon having negative charge is also not stable. Why? It says I am not that electronegative, so take away something from me.
mm,
So a carbon ion will be stabilized by electron withdrawing groups. Mane EWGs will stabilize the carbon ions,
mm.
and electron donating ones will be having the reverse effect.
Mm,
Clear? So the take home
yeah.
message from now on is carbocations stabilized by electron donating groups,
Mm,
carbon ions are destabilized by electron donating groups. Okay?
mm,
All right. What about free radicals which are going to be produced by. So again, a free radical, as you can see, the bond angle between HCH is 120,
mm,
and the odd electron will be there in one of the lobes of the P. Okay.
mm,
Since the electron count is 7, it should
mm,
be odd, so paramagnetic.
mm,
Okay. All right. Now let us talk about something over here. As you could see again in the syllabus, it is in a different part. Electronic effects, which we are now covering now, we will be studying resonance, inductive effect, and hyperconjugation.
Mm.
Okay, so maybe
Mm.
only resonance today, maybe inductive effect today, resonance and
Mm.
hyperconjugation we will take up in the next class.
Okay.
So these are called permanent electronic effects.
Mm.
A inductive effect. This operates through a sigma bond. First thing you should know.
Mm.
Hyperconjugation may be called no bond resonance or Nathan Baker effect.
Mm.
So now you have to remember all these names.
Mm.
And pi bond can also be used to move around electrons. So
Mm.
this is known as mesomeric effect or the resonance effect,
Oh.
roughly. Huh?
Yeah.
Okay. Finished writing?
Huh?
You wrote it?
Yeah, I got it.
Everything you wrote, right?
Yeah.
Okay, good. Now you can see inductive effect, like I
Mm.
said, this will be only operating when we have atoms which are having difference in electronegativity.
Mm.
So if a carbon is joined to another carbon, there is no inductive effect operating between them.
Mm.
That means if you have simply methane, uh,
Mm.
not methane, simply hexane or
Okay.
ethane, between the
Mm.
two carbons there is no inductive effect.
Oh.
But if you have a chlorine and a carbon,
Mm.
then there is inductive effect.
Mm.
How so? Because now carbon is less electronegative, chlorine is more electronegative.
Mm.
So there will be some development of negative charge on the chlorine. So let's say we have some, follow the pointer, we have some carbon, we have a X which is more electronegative. So we will
Mm.
say there will be development of some polarity between the two bonds.
Mm.
So what is the polarity like? Delta negative charge will be on the electronegative atom X,
Mm.
delta positive charge will be on the carbon,
Mm.
and the group that is pulling the electron density from away from the carbon.
Mm.
So we are thinking like when this bond is formed, we have no idea about the C and X electronegativity.
Mm.
The electron pair is almost lying in the middle,
Mm.
just like a true mutual account. Huh? I invest some money, you invest some money, both the money belongs to us. Okay,
Mm.
that is a treaty. Huh? But now I am showing a little bit of power, huh? Dadagiri, to you. Okay, so you
Mm.
will feel little scared and you will say, "Nana, you take some amount of the money I have invested, but don't do
Mm.
jhamela." Okay,
Mm.
don't do any fight with me. Okay, so what happens
Mm.
then? So even though the account is a mutual one,
Mm.
but I have more share,
Mm.
I have more power over the account, and you have less
Mm.
power. So even though they are making a bond which is a mutual one,
Mm.
but some amount of the electron density is always lying towards the X,
Mm.
and less is lying towards the C.
Mm.
So C now has positive charge, which means it has less power over the electron.
Mm.
X is having negative charge, which means it has more power over the electron pair, and it is towards it mostly.
Mm.
Okay, acha.
Mm.
So what we can say now in organic chemistry, if a atom or a group pulls electron density away from carbon via
Mm.
the sigma bond, it is called the
Mm.
minus I group.
Mm.
So
Mm.
you now get the idea which one will be called a minus I group.
X.
X. Acha. So minus I effect is a permanent effect, always operating,
Mm.
huh? Not under the
Mm.
influence of something,
Mm.
always there, present.
Mm.
Mostly in saturated molecules, that means the ones that are having sigma bonds,
Mm.
operate still the chain length of the carbon, chain length of three carbon atoms. Mane,
Mm.
you have a carbon here, Imagine there is another carbon at this position
mm,
till here,
mm,
and then on the fourth, someone here,
mm,
here it ends. So it is a
mm,
weak effect, not a very powerful effect.
mm,
So what we are seeing, so if you are having delta minus charge over here,
mm,
let's say we have x, this is delta 1, this is delta 2, this is delta 3.
mm,
Which is greater negative positive charge? This one, like
mm,
that. So as you are going to the end, this power is reducing.
mm.
Understood? This is what we mean to
Yeah,
say.
yeah.
All right. Now again, I've given you a reference. The order that you see over here is taken from a book called Jerry March.
Um,
You will see this book in library. It is called Advanced Organic Chemistry. Write the name of the book.
uh,
This is the book, best book for competitive exams. Okay. And again, your
can I know the author of the book?
Jerry March,
Uh,
JERRYMARCH.
mm,
Jerry March and Michael B. Smith.
mm, mm,
This is the best book. I mean, your net questions come from here. Net has three
mm,
sections: section A, B, and C.
mm,
So the C sections are from research papers. B
mm,
section questions are from this one,
mm,
or even C comes from here. This is
mm,
a book mainly for research students. Okay,
mm,
but even if you can read.
mm,
So now we have NF3.
mm,
So if you have positive charge, that is having the maximum minus I effect.
mm,
Then we have this NH3 plus,
mm,
NO2, okay, this SO3H,
mm,
CN, CHO, hmm,
mm,
COR. Now you might say, sir, how do I make a understanding of this if I just get
mm,
these things randomly? So
mm.
among the two positives, you can see the NF3 is greater than NH3 because F is more
That is
electron
mentioned.
withdrawing than H. Among the halogens, fluorine will be more electronegative than
Mm,
chlorine, then bromine, then iodine. Hmm?
mm, mm,
If you want to compare carbons over here, you see this is a sp hybridized carbon
mm,
because it is C triple bond hai, na?
mm,
And you know that sp s character increases, electronegativity increases. You have studied all this.
mm,
What about this guy? This guy is sp2.
mm,
This is sp.
mm,
This is also sp2, but it has a R, so it is donating some electron. That's why it is less electron withdrawing. Understood?
yeah.
Again, amongst ester,
Mm,
COOR and CONH2. O is
mm,
more electronegative than N.
mm,
That's why more withdrawing. Understood, beta?
mm,
Okay, good.
yeah.
Again, you see this is SP and this
Mm,
is SP2.
mm,
That's why this is more electron withdrawing than that guy.
mm.
Okay. So you have to develop a sense like this now.
What about OR and OH?
Okay, OR over here, we are considering that the carbon is more electron withdrawing than the H.
Mm, okay. But
Okay.
usually we say CS3 as like
Yes, more,
chloride.
more, yeah. Yeah, but this is again something to do with data.
Okay.
Okay, how about plus I effect?
mm,
The group or atom that push electron density to the carbon is called plus I.
mm,
So all the alkyl groups will be plus I.
mm,
O minus will be plus I. Even
mm,
the carboxylates will be plus I.
mm,
So in terms of donating power, if you think, carbon will be more donating because it is less electronegative. So minus on carbon is more electron donating. Then the minus on nitrogen, then the oxygen on nitrogen. Understood?
mm,
Clear?
mm,
Achha, tertiary alkyl group means what? A carbon joined to three more carbon.
mm,
Secondary means what? A carbon joined to two more carbon.
mm,
Primary means a carbon joined to one more carbon.
and, mm,
As I have already said, that more alkyl groups attached to a carbon, more donating power.
mm,
So that means a tertiary carbon. That means what we are trying to say. This is a butyl group, tertiary.
mm,
You have a secondary,
mm,
all right,
mm,
and you have a primary.
mm,
So this is more donating than that guy and then that guy.
mm,
That is what we are trying to say over here.
mm,
Now we are trying to understand how to apply these inductive effects and how to do some problems. We'll begin
mm,
with very simplistic ones and then we'll go into more critical ones.
okay.
Application of inductive effect is the topic. Stability of carbocation we are talking about.
Mm,
Directly proportional to presence of electron donating groups. We have discussed this part, or plus I
mm,
groups,
mm,
and inversely proportional to minus I groups.
that's it.
This is how we sum it up. So we are only doing things or explaining things on the basis of inductive effect. Okay. So this guy has three methyl groups, two
Mm,
methyl groups, one methyl group, no methyl group.
mm,
More the number of methyl groups, more is the plus I effect.
mm,
So this guy will be more stable than this one, followed
mm,
by this one, and at the end we
mm,
will have this one.
mm,
Okay.
mm,
This is a 3-degree carbocation, 2-degree carbocation, 1-degree carbocation, and this has no degree.
mm,
Let us have a look at the next example. This carbon over here we are talking about. Then this one,
mm,
follow the cursor, and this one. If you follow the
mm,
arms of the carbon, this carbon is joined to three
mm,
carbons.
mm,
Okay,
mm,
this carbon is joined to two such carbons, and the one that is not shown is the hydrogen.
mm,
This carbon is joined to only one carbon over here, the one that is not shown because these are line diagrams. So in
mm,
line diagrams, we only show the carbon chain and not the hydrogens.
yeah.
So the one that is joined to three carbons, okay,
Mm,
if you just count the number of carbons it is joined to,
three cartons.
three is more stable than two, is more stable than one.
Mm,
Agreed? Okay.
yeah.
Now out here we see
Mm,
we are getting ethyl carbocation, okay,
mm,
and then its derivative ones. We
mm,
have a Br, we have a Cl, and we have a F joined to the beta carbon because I am assigning this carbon having the positive charge or bearing the positive charge as alpha.
mm,
Okay.
mm,
So now if you look at the electronegativity order, which is called chi F greater than chi Cl greater than chi Br greater than chi H.
mm,
So we know electron donating groups stabilize carbocations and electron withdrawing groups destabilize carbocation.
mm,
Out here, what is important to notice is that the positions of the substituents are not
mm,
changing. So
mm,
distance variation is not a factor over here, that is same. We have to
mm,
look and judge the stability of carbocations
mm,
deciding on the factor. What is the order of electronegativity?
mm,
So one that is having fluorine will be destabilized the most
mm,
because fluorine is more electronegative.
mm,
So the most stable will be the ethyl carbocation, followed by the one that is having attached to bromine, followed by the one having the chlorine, and the last one
mm,
will be the fluorine.
mm,
Clear? Now
mm,
let us do a problem in which distance is a factor. As we
okay.
could see over here, we have a butyl carbocation.
Mm,
Excuse me. Now we have over here in the alpha position a fluorine, then in the beta position we have fluorine, and in the gamma position a fluorine.
mm,
So this is the electron withdrawing group. So the further away it moves away from the positively charged carbocation,
it's more stable.
right? So that way we have the order.
Mm,
Now one more problem we have in which we are taking to or we have to use the inductive effect order.
mm,
So obviously the one having the NO2 group, if you check the series of minus I effect groups, we have NO2 followed by F, and over here we have OH. The order is NO2F and OH minus I effect.
mm,
So that way if you think it's not loading.
mm.
You remember when we began?
Uh,
At what time?
uh, 12:30 or something.
So it's almost like 2 hours, na?
Oh, mm,
I think we should give it a quit.
mm,
Yeah.
yeah.
Otherwise it will be too much for you.
No, it's not.
It's okay, right? So okay.
Yeah.
Yeah. So we will tell you when we can do the next one.
Mm.
Any idea? Can you give me an idea when you are free?
On the working days, I'll be free after 6.
Okay, fine. So I'll provide in a time. Okay, because there was
But
some.
next Friday, I was doing an internship, so it will be ending on Friday.
Hmm.
So I'll be traveling back home, so I won't be free on Friday.
No, next Saturday, Sunday we are doing at the same time, I believe.
Okay.
From 12 only we'll
Okay.
start. Huh?
Yeah, Sunday is fine.
Okay. All right. Okay. Bye bye.
Yeah.